Section 7.4 is on partial fractions. The techniques we're going to use in this section are useful for integrating this type of integral, where you've got integral of a rational function. Now, we already know how to do integrals of some rational functions if the denominator is sufficiently simple. And the idea behind partial fractions, which we'll get to shortly, is if you have a complicated denominator, break it up into a bunch of fractions added together where the denominators are simpler. So the stuff we need to keep in mind are a handful of integrals where the denominators are simple. So let's just review those quickly. Let's see. If you've got the integral of 1 over x, that gives you natural log of absolute value. And if you have integral of 1 over mx plus b, it gives you 1 over m times natural log of mx plus b plus c. This one right here actually is what you'd get from here if you used u substitution. And notice both of these have a linear factor on bottom. Just one linear factor, either just a x or mx plus b. We know that's a line. So don't use the natural log if you have something that's not linear on the bottom. The rest of these examples have something squared on the bottom. This guy right here, this isn't necessarily one you'd memorize, but you get that one by changing it to integral of x to the minus 2, and then using the power rule on it. This one, you should have seen this one in Calc 1. If you integrate 1 over x squared plus 1, you get arctan of x, or inverse tan of x. And if instead of a 1, if you have some other number here, that affects things and gives you 1 over a arctan x over a plus c. This formula is on the formula sheet that I put in, I think it was the material for section 7.1. It might have been 7.2, I'm not sure. But anyway, this one is one on the sheet that I have to refer to. I've got it here on my orange formula sheet. And this last one, notice it's got an x on top and x squared plus a squared on bottom. So this one, notice I don't have anything that shows what it's equal to. For this problem, the bottom is x squared plus a squared. So if you let u equal x squared plus a squared, du is going to be 2x dx. And so divide both sides by 2. We could do that and just handle this one with a u sub. So these are kind of the building blocks that we're going to need for this section. And when we look at more complicated problems where we have a more complicated denominator like this or this, we're going to try to break this down somehow into simpler things that we can deal with. So we'll look at case 1 in the next video.